Almost every home has one of these. It's small, quiet, and easy to ignore, but it powers nearly everything we do online. The moment your phone connects, an invisible conversation begins between the phone and the router. Instead of using cables, Wi-Fi sends information through invisible radio waves that travel through the air. Within seconds, your phone can stream videos, download files, and browse websites, all thanks to those invisible signals. But have you ever stopped to wonder what those signals really are? How can something invisible carry so much information? The secret lies in radio waves. The same type of electromagnetic waves used for radio and television, but designed to carry digital information. The biggest difference is simple. Ethernet uses a physical cable, while Wi-Fi sends the same information wirelessly through the air. To understand how Wi-Fi works, we first need to answer one important question. What exactly is Wi-Fi? Before we understand how Wi-Fi works, let's answer the most basic question. What exactly is Wi-Fi? Many people believe Wi-Fi stands for wireless fidelity. Surprisingly, it doesn't. Wi-Fi is simply a brand name created for wireless networking technology. Wi-Fi is a way for devices to communicate without cables. Instead of sending information through wires, it sends data through radio waves. These radio waves travel through the air at nearly the speed of light, allowing information to move almost instantly. Here's something many people don't realize. Wi-Fi and the internet are not the same thing. Think of Wi-Fi as the bridge between your devices and your home network. It simply delivers your data to the next step. Your phone, laptop, smart TV, and tablet can all communicate with the same router at the same time. Now that we know what Wi-Fi is, it's time to answer the bigger question. How does it actually send information through the air? Imagine you tap a video on YouTube. It looks instant, but behind the scenes, your phone has already begun requesting millions of pieces of information. Computers don't send an entire video at once. Instead, they break everything into thousands of tiny pieces called data packets. Think of each packet like a small envelope. It contains part of the information along with instructions telling it where it came from and where it needs to go. Your router receives these packets, organizes them, and prepares them for wireless transmission using radio waves. Instead of pushing electricity through a cable, the router converts the packets into radio signals and broadcasts them through the air. Your phone catches those radio waves using its Wi-Fi antenna, then converts them back into the original data packets. Once all the packets arrive, your phone puts them back together in the correct order, creating the video you watch on your screen. So far, we've only seen how information travels between your phone and the router. But where does that information come from in the first place? That's the next part of the journey. Your router can send data around your home, but it can't access the internet by itself. First, it passes your request to another device called a modem. The modem acts like a translator. It converts your home's network signals into a format that your internet service provider can understand. From there, your request travels through high-speed cables. In many areas, these are fiber optic cables that use pulses of light instead of electricity. Your internet service provider, or ISP, receives your request and sends it toward the correct destination on the internet. If you're watching a YouTube video, your request eventually reaches one of YouTube's data centers, where thousands of powerful servers store and deliver content. The server doesn't send one giant file. Instead, it sends thousands of small data packets back to your home as quickly as possible. Those packets return to your modem, pass through the router, and finally reach your phone, where they're reassembled into the video you see. In just a fraction of a second, your request travels thousands of kilometers and back. But if that's true, why does Wi-Fi sometimes become slow? Let's find out. Have you ever wondered why your Wi-Fi is fast one moment, then suddenly starts buffering the next? The first reason is distance. The farther your device moves away from the router, the weaker the radio signal becomes. Walls, floors, and even large furniture absorb or weaken radio waves. The more obstacles in the way, the weaker the connection. Every connected device shares the same Wi-Fi network. The more devices that are actively sending and receiving data, the busier the router becomes. Nearby Wi-Fi networks can also interfere with yours. In apartments or crowded neighborhoods, many routers may be competing on the same channels. Some household electronics, such as microwave ovens and certain wireless devices, can briefly interfere with older 2.4 gigahertz Wi-Fi signals. A simple change in router placement can make a big difference. Keeping it in an open, central location helps the signal reach more areas of your home. So Wi-Fi isn't just about speed. It's also about signal strength, interference, and smart placement. But one important question still remains. How do we keep all this wireless data secure? Every time you connect to your home Wi-Fi, your information isn't sent openly through the air. It's protected using powerful encryption. Your Wi-Fi password is like the key to your home. Only devices with the correct password can join your network. Before your data leaves the router, it's scrambled into unreadable code. Even if someone intercepts it, they can't understand it without the correct encryption key. Wi-Fi technology continues to improve. Newer standards like Wi-Fi 6 and Wi-Fi 7 deliver higher speeds, lower delay, and better performance when many devices are connected. Let's quickly recap the journey. Your phone sends a request to the router. The router passes it to the modem, then your internet service provider, and finally to a data center. Thousands of tiny data packets travel back the same way, arriving at your phone in milliseconds. Your device puts them together to create the video, website, or message you see. Every video call, every online game, every movie you stream, and every message you send depends on billions of invisible radio waves carrying information around the world every second. The next time your phone connects to Wi-Fi, you'll know there's an incredible journey happening behind the scenes, one powered by radio waves, light, and billions of tiny data packets. Thanks for watching Knowledge Loop. If you enjoyed this video, don't forget to like, subscribe, and join us for more amazing explanations of how our world works. Thanks for watching. Please subscribe, like, and comment for more videos.